Russia sold Iran the weapons that were supposed to protect it. Russia sold Iran the S-300 surface-to-air missile system, a weapon that Russian marketing materials describe as capable of engaging stealth aircraft at ranges exceeding 150 kilometers. Russia sold Iran the Kilo-class submarine, a diesel-electric boat that NATO called the Black Hole because of its ability to disappear. Russia sold Iran the Qishm-31 anti-ship missile, the Tor-M1 point defense system, and dozens of other weapons platforms that formed the backbone of Iran's military capability. Every single Russian weapon system that Iran used during Operation Epic Fury failed. Not some of them, not most of them, every one. The S-300 did not shoot down a single American aircraft. The Kilo submarines were found and destroyed within 12 hours. The Tor-M1 point defense systems were overwhelmed by the volume and sophistication of the American attack. The coastal anti-ship missiles never reached an American ship. The air defense network that Russia helped Iran build over 2 decades was dismantled in less than 48 hours. This is the story of why Russian weapons failed in Iran. And this is the story that is destroying Russia's defense export business, because every nation that bought Russian weapons is now asking the same question. If these weapons could not protect Iran, can they protect us? This is naval depth. To understand why Russian weapons failed in Iran, you need to understand a fundamental truth about the global arms market. Russia does not sell its best weapons to export customers. Russia sells export variants, downgraded versions that are less capable than the systems Russia keeps for its own military. This is standard practice in the arms industry. The United States does the same thing. No nation sells its most advanced military technology to foreign customers without modification. But the gap between what Russia keeps and what Russia sells is larger than most customers realize. The S-300PMU-2 that Iran purchased is the export variant of the S-300 family. It uses older radar technology than the S-300V4 that Russia deploys for its own air defense. Its software has been modified to prevent Iran from integrating the system with non-Russian sensors and weapons. Its electronic warfare resistance, the ability to continue operating while being jammed, is significantly lower than the domestic Russian version. Iran knew this. Iran attempted to compensate by developing its own indigenous air defense system, the Bavar 373, that was designed to work alongside the S-300 and fill gaps in coverage. But the Bavar 373 was itself an untested system that had never been used in combat. Its radar, its missiles, its command software, all were Iranian-developed, and all were unproven against a first-tier adversary. When American EA-18G Growlers began jamming Iranian radar on the morning of February 28th, the S-300's export-grade electronic warfare resistance was immediately exposed as inadequate. The AN/ALQ-249 next-generation jammer that the Growler carries is specifically designed to defeat Russian-made air defense systems. It has been developed, tested, and refined over decades, with each generation of jammer designed to counter the specific vulnerabilities of the specific Russian systems it is expected to face. The S-300's radar operates in specific frequency bands. The ALQ-249 knows these frequency bands. The S-300's radar uses specific signal processing techniques to filter out jamming. The ALQ-249 knows these techniques and is designed to defeat them. The S-300's radar switches frequencies in specific patterns to evade jamming. The ALQ-249 knows these patterns and follows the frequency changes faster than the S-300 can execute them. This is not a fair fight. This is an American electronic warfare system that has been specifically engineered to destroy a Russian air defense system. The American system knows the Russian system intimately, knows its frequencies, its timing, its algorithms, its vulnerabilities. The Russian export system, by contrast, knows nothing about the American jammer. It was not designed to counter the ALQ-249. It was not updated to address the ALQ-249's capabilities. It was sold to Iran in a configuration that was already obsolete against the latest American electronic warfare technology. The result was predictable. When the Growlers turned on their jammers, the S-300 radar screens went white with noise. The operators could not distinguish real aircraft from false targets. The system could not generate weapons-quality tracking data. The S-300 missiles, even if launched, could not be guided to their targets because the radar that guides them was blinded. Some S-300 batteries attempted to engage American aircraft using their backup optical tracking systems, television cameras, and infrared sensors that can track aircraft visually without using radar. But optical tracking has severe limitations. It works only in clear weather and only at relatively short ranges. It cannot track multiple targets simultaneously. And most critically, it cannot guide the S-300's semi-active radar homing missiles, which require radar illumination of the target during the terminal phase of flight. The S-300 batteries that activated their radars were destroyed by AGM-88 HARM anti-radiation missiles within minutes. The HARM homes in on radar emissions when an S-300 radar transmits. The HARM detects the transmission, calculates the radar's location, and flies directly into the antenna at Mach 2. The S-300 operators faced an impossible choice: turn on the radar and be destroyed by HARM, leave the radar off and be unable to engage any targets. Most chose to leave the radar off. The S-300 batteries that survived the opening hours of Operation Epic Fury survived because they did not turn on, meaning they contributed nothing to Iran's defense. They were billion-dollar paperweights. Now let us discuss the Kilo-class submarines. Russia sold Iran 3 Kilo-class submarines in the 1990s. The Kilo was, at the time, a genuinely capable diesel-electric submarine. In the hands of a well-trained crew with proper maintenance, the Kilo can be very difficult to detect and very dangerous to surface ships. But the Kilos that Russia sold Iran were the Project 877 EKM export variant, not the improved Project 636 Varshavyanka, that Russia later developed for its own navy and for more favored export customers like China and Vietnam. The 877 EKM has older sonar, older fire control systems, and a noisier propulsion system than the 636. The difference is significant. The 636 is estimated to be 5 to 10 decibels quieter than the 877 EKM, a difference that translates directly into detection range. More importantly, the Kilos that Iran operated in 2026 were 29 to 33 years old. Submarines are complex machines with thousands of moving parts, hundreds of hull penetrations, and dozens of systems that must work together to keep the boat operational and, critically, quiet. Every pump, every valve, every bearing, every pipe degrades over time. Rust forms, seals deteriorate, anechoic tiles, the rubber coating that absorbs sonar pulses, detach from the hull. The submarine gets louder with every year of service. Russia was supposed to provide overhaul services for Iran's Kilos, but international sanctions, payment disputes, and logistical challenges meant that the submarines did not receive the regular depot-level maintenance that they required. Iran attempted to perform maintenance domestically, but Iranian shipyards lacked the specialized equipment and expertise to work on Russian submarine systems. The result was submarines that were significantly noisier than their design specifications, submarines that American sonar could detect at ranges far greater than a properly maintained Kilo. The American anti-submarine warfare community had been tracking Iran's Kilos for decades. They had recorded the acoustic signatures of each submarine during every deployment. They knew exactly how loud each boat was. They knew the specific frequencies of each boat's machinery noise. When the order came to find and destroy Iran's submarines, the American ASW teams knew exactly what they were listening for. All 3 kilos were eliminated within 12 hours. The Tariq was destroyed at her berth. The Nor and the Yuns were found at sea by a combination of P-8A maritime patrol aircraft and Virginia-class attack submarines. They were tracked, targeted, and torpedoed with the same systematic efficiency that characterized every other dimension of Operation Epic Fury. The Tor-M one-point defense system, another Russian export, failed for different reasons. The Tor is a short-range air defense system designed to protect military installations and formations from low-altitude air attack. It is a capable system against older threats, cruise missiles, helicopters, and low-flying aircraft. Iran deployed dozens of Tor systems around its military installations. The Tor failed because it was overwhelmed. The American attack used time-on-target coordination, timing the arrival of multiple weapons from multiple directions to strike within seconds of each other. A single Tor battery can engage 2 targets simultaneously. The American attack presented 10, 20, or 30 targets simultaneously. The Tor operators could engage 2 of them. The other 8, 18, or 28 struck their targets. This is a fundamental limitation of point defense systems. They can protect against limited attacks. They cannot protect against saturated attacks from a first-tier military power that has the intelligence, the weapons, and the coordination to overwhelm any point defense. The pattern across all Russian weapons systems was consistent. The S-300 was defeated by electronic warfare. The kilos were defeated by acoustic superiority. The Tor was defeated by saturation. The coastal anti-ship missiles were defeated by a combination of jamming, suppression, and preemptive strike. Let us examine the coastal anti-ship missiles in detail, because this failure has the most direct relevance to China's strategy. Iran deployed Nor anti-ship cruise missiles based on the Chinese C-802 design in coastal batteries along the Persian Gulf. These missiles have a range of approximately 120 kilometers and carry a 165-kilogram semi-armor-piercing warhead. They are guided by inertial navigation during the cruise phase and active radar homing during the terminal phase. Against an undefended target, the Nor is a lethal weapon. But no American target was undefended. The American defense against Iranian anti-ship missiles operated in multiple layers. The first layer was preemptive. Tomahawk cruise missiles and JDAM bombs destroyed Iranian coastal missile batteries before they could fire. Intelligence had identified the locations of most Iranian missile sites through satellite imagery, signals intelligence, and human intelligence gathered over years. These sites were priority targets in the opening strikes. The second layer was electronic. The EA-18G Growlers jammed the radar seekers of any missiles that were launched. The Nor's active radar homing head operates on a specific frequency band. The American jammers know this frequency band and can generate false targets, noise jamming, or deceptive signals that cause the missile to miss or to lock onto a decoy rather than a real ship. The third layer was kinetic. The Aegis combat system aboard American cruisers and destroyers can detect, track, and engage incoming anti-ship missiles at ranges exceeding 100 kilometers using SM-2 and SM-6 surface-to-air missiles. The Aegis system can simultaneously track hundreds of targets and engage dozens of incoming missiles at the same time. Against the relatively slow, non-maneuvering Nor missile, Aegis intercept probability is extremely high. The fourth layer was the last resort. The Phalanx Close-In Weapon System, a radar-guided 20mm Gatling gun that fires 4,500 rounds per minute at incoming missiles that penetrate all other defenses. The Phalanx has a range of approximately 1.5 kilometers and is designed to destroy missiles in the final seconds before impact. No Iranian anti-ship missile penetrated even the second layer. The combination of preemptive destruction and electronic warfare eliminated the threat before the kinetic defenses were needed. This layered defense model is directly relevant to China's anti-ship missile strategy. China's DF-21D and DF-26 anti-ship ballistic missiles are more advanced than anything Iran possessed. They fly faster, at ballistic speeds, rather than subsonic cruise speeds. They use different guidance methods, satellite navigation, and over-the-horizon radar rather than simple radar homing. They are harder to jam and harder to intercept. But the layered defense concept applies regardless of the specific weapon. America's defense against Chinese anti-ship missiles would follow the same layered approach. Preemptive strikes against launch sites, electronic warfare against guidance systems, kinetic intercept using SM-3 and SM-6 missiles, and point defense as a last resort. The specific countermeasures would be different, but the concept would be the same. And the core lesson from Iran applies. If your anti-ship missiles depend on systems, radars, communication links, targeting data, that the enemy can degrade or destroy, then your anti-ship missiles may never reach their targets. China's DF-21D depends on a kill chain that includes over-the-horizon radar, satellite targeting, and real-time communication between the radar, the command center, and the missile. If any link in that chain is broken, if the radar is jammed, the satellite is blinded, or the communication link is severed, the missile cannot be guided to a moving ship. It becomes a very expensive ballistic projectile falling into an empty ocean. American planners have spent 2 decades designing systems to break exactly that kill chain. The SM-3 missile can destroy Chinese satellites. American cyber operations can disrupt Chinese communication networks. American electronic warfare can jam Chinese over-the-horizon radar. The American approach is not to intercept the DF-21D in flight, although that capability exists, but to prevent it from ever being accurately launched. Iran's experience demonstrates this concept in practice. Iran's weapons were not defeated in flight. They were defeated before launch by destroying the launchers, jamming the radars, and severing the communications. The weapons themselves may have been capable. The systems that supported them were not. And this pattern has consequences that extend far beyond Iran. Russia is one of the world's largest arms exporters. Russian weapons are used by dozens of countries across the Middle East, Africa, Asia, and Latin America. The S-300 and S-400 are deployed by Turkey, India, China, Algeria, and others. Kilo-class submarines are operated by India, China, Vietnam, Algeria, and others. Tor and Buk air defense systems are deployed by dozens of nations. Every one of these customers watched Russian weapons fail in Iran. Every one of these customers is now reassessing the value of their Russian military equipment. Everyone is asking, if the S-300 could not shoot down an American aircraft over Iran, can my S-400 shoot down an American aircraft over my territory? The answer may be different for each customer. The S-400 is a more capable system than the S-300, and some customers receive more advanced export variants than Iran did. But the doubt has been planted. The demonstrated failure of Russian weapons in combat has fundamentally undermined confidence in Russian military technology worldwide. India, which operates S-400 batteries, Kilo-class submarines, and numerous other Russian systems, is reportedly accelerating its program to diversify its weapon suppliers, shifting toward French, Israeli, and American systems. Vietnam, which operates Kilo submarines, is exploring options for Western submarine technology. Algeria, one of Russia's largest arms customers, has reportedly frozen negotiations for additional Russian weapons purchases pending a review of the Iran experience. The financial consequences for Russia's defense industry are potentially catastrophic. Russia's arms exports generate approximately $15 billion per year in revenue, a critical source of hard currency for the Russian economy. If major customers reduce or cancel Russian weapons purchases, the impact on Russia's defense industrial base would be severe. And there is a deeper strategic consequence. Russia's arms exports are not just a business, they are a tool of foreign policy. Russia uses weapons sales to build relationships, to gain influence, and to create dependencies. Countries that buy Russian weapons need Russian spare parts, Russian maintenance, Russian training, and Russian upgrades. This creates a long-term relationship that gives Russia political leverage. If countries stop buying Russian weapons, if the Iran experience convinces them that Russian weapons cannot protect them against American military power, Russia loses not just revenue, but influence. Russia loses the network of military relationships that weapons exports create. Russia becomes less relevant, less powerful, and less able to project influence beyond its borders. Operation Epic Fury may have cost Russia more than it cost Iran. Iran lost a navy. Russia may be losing its position as a global arms supplier, and no amount of marketing, no amount of glossy brochures about S-400 capabilities or hypersonic missile test results can undo the image of Russian weapons burning on the docks of Bandar Abbas. The global arms market runs on two things: specifications and combat records. Russia's specifications are impressive. Russia's combat record, from Ukraine to Iran, is not. Consider the timeline. In 2022, Russia's military performed poorly in Ukraine, failing to capture Kyiv, losing the flagship Moskva to Ukrainian missiles, struggling against a military that Russia was supposed to overwhelm in days. The global arms market noticed. Countries that had been planning to purchase Russian systems began to hesitate. In 2026, Russian weapons failed comprehensively in Iran, not because of poor Iranian training or maintenance, but because American electronic warfare, American acoustic technology, and American tactical doctrine rendered Russian systems ineffective. The global arms market noticed again, and this time the impact was not hesitation, but cancellation. The specific comparison that arms buyers are making is devastating for Russia. American weapons systems, Harpoon missiles, JDAM bombs, Mark 48 torpedoes, HARM anti-radiation missiles performed exactly as advertised. They hit their targets. They destroyed what they were supposed to destroy. They worked. Russian weapons systems, S-300 missiles, Kilo submarines, Tor-point defense, Noor/C 802 anti-ship missiles did not perform as advertised. They did not hit their targets. They did not protect what they were supposed to protect. They did not work. This creates a simple equation for any country considering a weapons purchase. American weapons work in combat. Russian weapons do not work in combat against American forces. If you are buying weapons to defend yourself against America or American allies, Russian weapons are not the answer. This equation is simplistic. There are many scenarios where Russian weapons would be effective against adversaries that lack American electronic warfare capability, against adversaries that lack American acoustic technology, against adversaries that lack American intelligence and coordination. Russian weapons are adequate for many regional conflicts. They are not adequate against the United States, but the perception matters more than the nuance. The image of Russian weapons failing in Iran will dominate the global arms market for years. Every sales pitch for an S-400, every proposal for a Kilo submarine, every negotiation for a Sukhoi fighter will be shadowed by the question, but what about Iran? And in the arms market, combat records always win. This is Naval Depth. Subscribe and stay with us as this story continues.